Check the mic and make sure it sound right, boys.
Hello, Madhu. How are you?
I'm good. How are
Uh,
you, Varun?
I'm fine. And to my viewers, we have guest today. His name is Madhu Kashyap. And to tell about him, he's one of the smartest guy. And he got many awards from ESA, European Space Agency, and Indian Science Congress as Young Scientist Award and Young Researcher Award. And I'm very glad that Madhu, you are here and on our podcast, The Arrow. And viewers, if you like it, please press the like button, share it, and yeah, do subscribe. We want many more subscribers than what we have right now. So yeah, with that out of the way, Madhu, please introduce yourself to my viewers.
Hi, everybody. Thank you, Varun, for that nice line of introduction. So, my name is Madhu Kashyap, as you guys already know. I'm an astrophysicist from Bengaluru. I hail from Bangalore. I'm a Young Scientist Awardee from Indian Science Congress and a Young Researcher Awardee from European Space Agency, Netherlands. Actually, the things I work on, basically my research area of interest is exoplanets. Exoplanets or something planets outside our solar system. We know our solar system has 8 planets. Now we have made sure Pluto is no longer a planet in our solar system because we have an international astronomical union where we have certain criteria for some celestial objects to qualify as a planet. So since Pluto did not qualify those parameters, we have to vote Pluto out of being a planet. So Pluto is no longer called as a planet in our solar system. We have 8 planets. So what I do is I work on planets outside the solar system. Exoplanets are planets outside the solar system. We know there are many stars. Our sun is one of our stars which we see every day, but in the night sky you see many millions and billions of stars, and we have actually billions of galaxies, and each galaxy has billions and billions of solar systems. So each solar system has some stars have planets. Some stars have single planets, some stars have multiple planets like us. Ours is a multiple planetary system. So there are very interesting aspects when we look at the night sky in the night. Every object, like or you would have seen the famous constellation Orion. The very easiest way to navigate the sky is to look at the constellation Orion. If you are an amateur astronomer, just go and look at the night sky and look for these three stars, three straight dots, where it is basically the belt of the hunter. So you have seen a hunter position, right? So it will be a hunter position, and the three stars present the belt of the hunter. And you can, if you come below that, there will be three faint dots. That's the sword of the hunter. Okay, this is one of the way to start looking, get inspired to look at the skies. So you can see this constellation Orion. Once you look at this pattern, you can use many softwares like Stellarium and Google Maps, where you can just use your mobile phones and locate what are the constellations they are about, because they all have motion sensors along with it. So that's how you start your amateur observation without any telescopes or without any instruments, with your naked eye. It's very hard to look at stars in the city lights, because we have a lot of light pollutions and air pollutions, and we can't see much. So we have to look at constellations at very dark places where light pollution is not there. There are no street lights, especially in forests or any dark regions. We always like, everybody says full moon is good to look at, but we as astronomers want to look at no moon day, because we don't want moonlight to pollute the sky, so that moonlight to distract other stars. We can't see other stars because moonlight is so bright. So you can see other stars. For us, observing those stars are very important. So we look at the skies when there is no moon day. So that's how we start. So this is how you can see the every, just like sun rising and setting, all the constellation rise from the east and set in the west. Keeping that in mind, as I told you, there are many stars and billions of planets, even possibly many planets. So far we have found 4,000 exoplanets, 4,000 only. And the first person who did this was Alexander Vonkov in the year 1992. um, and the people who worked with him won the Nobel Prize recently. So Mayer and Quidler so won the Nobel Prize on detecting the first exoplanets. It was in the constellation Pegasus B. Pegasus constellation. Okay, the star name is Pegasus, and the planet which was formed was called as Pegasus B. We use the nomenclature for stars like Pegasus and like Sun. If we have to nomenclature our own solar system, Sun will be called as our host star, Mercury will be called as Sun A, and Venus will be called as Sun B, and our Earth will be called as Sun C. Those A, B, C are basically the nomenclature, the way we nomenclature and we name those planets. Okay, and this is named after the host star Pegasus. So Pegasus B is a star that was done. So what my work was basically on was to find. I wanted to work on finding the surface temperature on these exoplanets, and you can't go to sun or moon and touch what is the temperature and tell how hot or cold something is. So what we did, and we don't have enough technology to send probes outside the solar system and look at those planets as well. So what I did was I came up with a theoretical modeling in which I found a formula, me and my team. I have a supervisor, she's a Russian astronomer, Margarita Safanova. So she is the one who guided me along with other people. So we found a formula to find the surface temperature on exoplanets, planets outside the solar system. For this, I received the Young Researcher Award from European Space Agency, Netherlands. Actually, my wife is a biologist, so we went to Himalaya for a trip, but and I have a collaboration with a Poland scientist, Professor Lucas. So he wanted us to collect some sample. We were working on something called as tardigrades. Tardigrades are microbes which can survive in space. Okay, these are a small tiny water base. It has 6 legs, small tiny. It can survive in water and it can survive in very extreme conditions like space. You know, if you go outside the Earth's magnetic field, there is high energy cosmic radiation in the space. We can't survive. We will die by cancer. But these tardigrades can survive.
Yeah, and they look like aliens too. I mean,
Yeah, they
look
do
at
look
their
like, because they have 6 legs.
yeah, 6 legs,
And
and
they
their
have a,
face is like with so many teeth.
yeah,
They look
exactly.
scary, even though
Yeah,
they are so
and
small.
these tardigrades have a hardcore shell. So it's just like a tortoise. They have a shell. Okay, they can, when they are outside the shell, they are called as anhydrotic, and when they are inside, they are called as cryptobiotic when they are inside the shell. So in the cryptobiotic state, they can survive in very harsh conditions like space, even though there are so much high energy cosmic radiations which can kill us. So what we did was we collected a few sample in the purest form in Himalayas when we went for a hike, and we did discover a new species for science in the form of tardigrades. And me and the Polish collaborator, we worked on something called as finding a home for tardigrades on exoplanets, whether any of these tardigrades can survive on exoplanets. This got me the Young Scientist Award from Indian Science Congress Association. And then later on, actually, to be honest, I started my bachelor's degree from St. Joseph's, and I completed there, and then did my master's from Jain University in Bangalore. Then I went to do my PhD at Florida Institute of Technology in United States, under Dr. Darin Ragozin, one of the brightest minds in exoplanets. Unfortunately, due to my financial conditions and something I had to come out due to my personal reasons, I have to come back from the United States. I dropped out of my PhD, and I started my MPhil with Christ University in collaboration with Indian Institute of Astrophysics, IIA. Here, this is where my MPhil work was, where I received the Young Researcher Award from ESA in Netherlands. Then again started, and also I started working as an assistant professor in a degree college in Bangalore. Along with it, I started working as a part-time researcher. Then I continued my PhD in BE stars. Right now, I did work on exoplanets. Now I have moved on to an open program called BE stars. So what these BE stars are, basically we have a classification in which we can name these stars. So the way we classify the stars are based on their temperature, how hot something is, how cold something is. So we classify them as O, B, A, F, G, K, M. The way you remember this O, B, A, F, G, K, M is O oh boy, a fine girl or guy, according to your convenience, kiss me. So OBFJKM, that's how you remember. O is being the hottest star, M is being the coldest star, and our sun is a G type star. Our sun is a G type star. I work on B type stars. After O comes B, so the hottest stars. So we have an open puzzle here.
Studied a lot, but at the start, what make you interested in stars? For the first question should be that what made you interested in stars, and how did you develop that? Because
Passion.
everybody is intelligent in something, and everybody has passion about something. Why did you pick up stars?
The reason was I was in my ninth grade. I had a very good teacher, and he said one point. He said electricity and magnetism were two different subjects, and when electricity married magnetism, that is electricity. We know light is an electromagnetic wave. So electricity combined with magnetism that comes out to be the speed of light. Light is an electromagnetic wave, and he said light is the only information that comes out from the space for us to understand the entire thing, like what they are made up of, how they are. Keeping just one single aspect in head, we are able to do so much. That fascinated me, and that pushed me. And also I did something called as REAP, Research Education Advancement Program, in during my bachelor's degree. I did not have my Saturdays and Sundays in my life during those 3 years. And during that time, I was taught by brightest scientists from IIA, IISC, and Raman Research Institute. They all motivated me to do this, and they used to take us to various field trips to look at. During then, the Asia's largest telescope was located in Kavalur, optical telescope in Kavalur. So that was one of the awesomest experience to have to begin with. Back then, I was an amateur who went as a field trip student. Now I use Kavalur telescope as an observer. So it has been a great journey that way. I just went as a visitor. Nobody gets access to those telescopes so easily, and getting time on observation time is one of the most challenging things as an astronomer. And now I'm happy in a position to get those times, and for a long no, for a number of years right now.
Yeah, I mean, I know how light pushed you into this field, because apparently I came to know very late that light is the only thing which does not have relative velocity compared to other things. Its velocity will always be the same, even if
Constant.
you are traveling very
Yeah.
high. So Einstein's theory of relativity does not fits with light,
Yes.
and it's a very interesting topic. So during your introduction, you talked about exoplanets.
Yeah.
First of all, what is exoplanet?
Hmm.
Number one. Number two, which you have to continue so it will be easier to explain, is that there is one search going on of a ninth planet in our own solar system beyond the Kepler belt,
Yes.
and people are researching about it. So, tell us about that.
Okay. To begin with, what is exoplanets? Planets outside our solar system. We know we have planets in our own solar system, but we are trying to find other solar systems. We call it as extrasolar because ours is solar system. Yeah, other than our solar system will be called as extrasolar. So those are extrasolar systems. In those, when we find planets, we call it them as exoplanets, planets outside our solar system. So the reason the hunt for planet is very important for us, because even we know Elon Musk is planning to make us a multiplanetary species. So it's very important we find as many planets as possible, because we have a lot of resources that we can use in the future once our technology is ready. So the current research what's going on beyond the Kepler belt is actually we are trying to fit on with the right mass and right orbital inclination. In order to qualify as a planet, we have many physical parameters. It should have the right mass, it should have the right radius, and it should have the right axis of rotation, and all those things, right orbit, so that it should have its own, or it should qualify as a sun's orbit for it to revolve around the sun. So if these are the parameters in which we are looking beyond the Kepler belt, if they, because we know many objects lie there, whether we call them as moons or some debris or some kind of asteroids, we have to make sure we have a proper shape, proper size, and proper mass. So until we attain that, the research keeps on going in that area. So that is one of the open problems right now that's being worked on. So keeping that in mind, exoplanets are very interesting. The reason is we know those planets are see if there's something called as habitable zone. If the planet is too close to the sun, it's too hot. If the planet is too far away from the sun, it is too cold. But for the Earth-like planet, the distance is just right to sustain water and host life. So we are the only planets we know that we host life. So we are keeping this model in idea, and we are trying to follow the water. So that's
And
how the search of exoplanets is going on right now.
that zone is known as Goldilocks zone.
Yeah, it's also
Yeah.
called as Goldilocks zones, circumstellar habitable zones.
Mhm.
So those are fairy names, Goldilocks zone. But the habitable zone is the astrobiological community's name of telling something is in the zone. And Mars is at the edge of our habitable zone. We have a theory called ancient Mars theory. So there is a paper, a very good paper in a very high standard journal. So what they say is this theory is like they believe that we are all from Mars. So the thing is, they have a mountain in Mars which ideally maps with the Mexican crater which we have on Earth. So we believe the part of the mountain flew towards the Mexican crater, making that crater happen. So that's the reason we believe we could be from Mars. We think Mars had life before Earth, according to that theory, and something really bad happened in Mars, and now we have a life on Earth. So that is one of the interesting papers that has been recently published in a
Yeah.
journal.
I have read information about something called panspermia.
Okay.
And panspermia is, I think, the same thing that actually the life started somewhere else
Yes.
and it came somehow to Earth,
Yeah.
asteroids or comets,
Yeah.
whatever. And that's how the
Yeah,
life and
that's
civilization came
basically,
to
yeah,
Earth.
the names may be different, but this is what they call it as ancient Mars. We are from Mars. So since it's a neighboring planet, there could be a possibility, we never know until we find, but we can't claim that because Carl Sagan says extraordinary claims requires extraordinary evidences. So we need to work more on that area as well.
So exoplanets, as you were telling, that planets outside of our solar system, right? And as I asked you that the ninth planet, which is discovered or it is supposed to be there out somewhere behind or beside the Kuiper belt. And the point is, how do you find a planet, first
Planets.
of all?
How do you find?
Because
Okay.
what I know is that we have Hubble telescope. I think it is the
Yes.
farthest which ever went, and the photos are not never good. And so, how do you find these planets? And
Actually, we have many telescopes, just like Hubble, we have Kepler, we have currently tests working for finding exoplanets. The first telescope to find planets was sent by French. It was called Carrot mission. So they launched this mission for the very first time. The techniques we use to find exoplanets are through something called as radial velocity technique, and another most popular one is called transit technique. Transit technique is nothing but if, for example, if there is a star, okay, and if there is a planet orbiting this star, what happens is you plot a brightness versus time scale, and you see a dip because of the eclipsing in the brightness. Looking at the dipness curve, we will be able to detect the existence of planet by measuring its mass and radius. All we are doing is just looking at the eclipses of those stars. So for how long and how big, whether the brightness is dipped enough to call it as an eclipse. So based on that, we will be able to detect those planets. Let me just share my screen and tell you show you the drawing of how exactly this thing happens. Okay, if I draw, this is brightness and this is time. Simple graph. What you do is you look at a star. Stars are never in this shape. Okay, stars are basically spherical shaped. So when there is a planet somewhere and it eclipses this planet, what
Mhm.
happens is when there is no planet, the brightness and time will be constant. When the planet eclipses this star, what happens is there is a big dip in this curve.
Mhm.
Based on this dip, we will be able to extract all the information of the planet. We can find what is the mass of the planet, what is the radius of the planet. Everything can be found out by just looking at this depth. So this is how we detect exoplanet. Sorry, this is how we detect exoplanets through transit technique. This is called as a transit technique. There are different ways. This is one of the most powerful and most used technique. We have something called as radial velocity technique, gravitational microlensing technique. We have direct imaging technique. So those are very little complicated compared to the transit technique. This is the most common and most widely used technique. And Kepler, after Carrot mission, Kepler went to space. Let me stop sharing the screen. Kepler went to space. Kepler was launched by NASA in 2009. So this is a space telescope similar to Hubble. But what they did was they used a technique, transit technique, to detect these exoplanets, and it found more than 3,000 exoplanets. And in my work with the surface temperature formula, we were able to find 29 Earth-like planets. And also we found a way to find Mars-like planets, which are very interesting, because we thought Mars is at the edge of the habitable zone, and the ancient theory Mars had life. So based on that, we went in search of Mars also. And recently Curiosity rover on Mars discovered methane on Mars, which predicts the presence of metabolic activity of some microbe. So if there is life on Mars, then finding Mars-like planets will become very important. So we found 12 Mars-like planet out of this 3,800 odd exoplanets from Kepler. Right now we have a new mission called TESS, Transit Exoplanetary Survey System, TESS telescope, which was launched by NASA recently, because Kepler lost its fuel. So now TESS is starting to find exoplanets. So this is what is the current state of finding exoplanets, and the future mission is an interesting one. It's called JWST, James Webb Space Telescope, which is one of the ways to find something called as biosignatures on exoplanets, which I will explain in detail when we talk about astrobiology in detail.
So, Madhu, I have one question. You said that we check if there is a planet around a sun or around a star. Is that how it dips the brightness of that star for that particular moment when it goes around that star and comes between Earth and that star?
Exactly.
Right. So there might be many stars who are so huge and planets who are so tiny. And how much time do you have to observe to confirm that, okay, this is a star, not an asteroid or a comet?
Okay, we usually see it in the scales of hours and days. So if the planets are huge, it will be for days, and if the planets are small, it will be in hour scale. We can measure its mass. We have various techniques to measure its mass, and we can also confirm them with another technique called as radial velocity technique. It is basically based on your school days Doppler effect of sound technique, but this happens with respect to light. Okay, so what happens is, if the planet is coming towards you, we take a spectra of that star. If the planet is coming towards you, you will see the spectral line shifting towards blue. If the planet is going away, the spectral line moves towards red. We know VIBGYOR is the spectra, right? So when I say blue, it is going towards the violet part. So when I say red, it is going towards the red part. And we won't go beyond red. The reason is far of red is infrared and far of violet is ultraviolet. So then we have to use different techniques. This is the only way we can do it with optical region. This we call it as visible wavelength region, also called as optical wavelength region. Beyond this, we have different telescopes. Like in India, we have something called as AstroSat, which is having ultraviolet capability of observing things. And also we have one more telescope in India, which is called as HCT, Himalayan Chandra Telescope, which I am currently observing with. So these are the observatories which will help you to observe these things. AstroSat is in space, and Himalayan Chandra Telescope is on the top of the Mount Saraswat in Hanley. So this works on infrared wavelength region, whereas this works on ultraviolet region, and we are talking with respect to Kepler in the optical wavelength region.
I see. You are saying that you observe through that telescope. How do you do that? I mean, do you have to really go there, or you just have everything on your computer?
everything on my computer. All I see is numbers, just like Rajesh Kutrupali says, if there are numbers coming 111, then you say the star is twinkling. So that's the only way we do it. So yeah, we look at, but we have something called as IRAF, using a computer program called as IRAF, image reduction analysis function. We do, if you want to become an astronomer, I will really suggest you to start working with only Linux, not to use Windows at all. So you have to get used to writing codes, because now astrophysics is totally computing. So you will be designing various types of something called as pipelines, where it is automated to observe things. So that's how we do things.
Um, Another point is that for me, astrophysicists are people looking through the telescope at the stars all the time. But I came to know quite late, or maybe quite recently, that actually it's all about numbers, graphs, and Excel sheets, and people
Yeah.
people decoding that. Okay, this might be looking like this.
Yeah.
Another thing is that how far we have gone to in search of planets.
We have come quite a lot, because since olden days, the main question is, are we alone in the universe? That question has haunted all of our human civilization for a long time. And Kardashev was one of the great scientists. We have a scale called as Kardashev scale. So what he said was, he gave a ranking or types to distinguish where we stand on finding other lives or any other as a whole thing, as a usage of power as a human civilization. So we are right now in rank 0, because we are just using the resources in our planets, and we are almost about to attain the proper 0 format, like we are able to extract all the resources from our planet. So when can we call ourselves as rank 1 planet, rank 1 species is, or type 1 species, is when we are able to extract, when we become multiplaneted species with ease, and then when we are able to extract some output energy from our sun. Like there is something called as Dyson sphere, which is a very famous one, where we want to build some engineering structure around our sun, and we want to extract all the power from our sun. So that will be rank 1 species or type 1 species. After that, once we become Star Trek level, or traveling to other planets, once we find a proper way of extracting energy and of our entire solar system, and traveling to different parts of our other solar systems, inside our, if we are able to go into other galaxies, maybe our nearest neighbor Andromeda galaxy. So when once we reach there, we will be type 2 civilization. And after this, we have something called as type 3 civilization, which goes towards our famous TV series Doctor Who, where we will be able to time travel. So that's where we will be reaching our ultimate scale. So this is the scale that is been set up. Some things are real science fiction to us, some things are already with us. So but that is the pattern in which the physics is flowing to work towards. So it's a very interesting age right now, what we are in right now. We may become multiplanetary species in next century or so.
Apparently, everything comes down to energy.
Yes.
Sometimes I think that actually that human civilization will grow once we start taking, or we start having energy as a right and not as a
Yes.
commodity. When energy
Exactly.
becomes right,
When
we
we
can do a
harness
lot of
energy
things.
without any consequences, then yes, absolutely yes.
And people can directly go on YouTube and search for this sphere which we
Dyson
were
sphere.
talking about.
Yeah,
I
Dyson
mean,
sphere.
they are extracting energy from our solar system, the outside our solar system, and that is fascinating to have a inkling of a future which we will not obviously will be able to see. I mean, it's maybe thousands of years in the future,
We hope
or
we
who
become
knows,
rank 1 when we are alive.
still
So
alive.
it
Yeah.
is still a possibility, because Elon Musk and Blue Origin and Virgin Galactica are doing great strides in space race. So maybe I wish to die on Mars. We never know.
Oh, I see. No, I want to visit. I don't want to live there. There are a lot of places on Earth which
Yes.
I have to visit. Um, Another point is that since we were talking about these exoplanets and then we harnessing energy, panspermia, the point is that you also said that you are into astrobiology.
Yes.
So, what does astrobiology consist of? Does it consist of the survival of biology on Earth, outside of the Earth, or does it confer with the point that we can find biology on other planets or other solar systems too?
Okay. Actually, the search is going in all the three directions as you have pointed out rightly. But the main point what we are looking is right to find a life on other planets. Rather than we going and putting some life there, we want to see whether there already life exists, alien life exists outside our. When we call it as alien, we are not talking about any spooky aliens. We are talking about microbial life forms. So we also call them as extremophiles. Extremophiles are some microbes which can survive in very hot and cold conditions. It should be able to withstand the heat of the desert, and it should be able to withstand the freezing cold of Antarctic region. So when we talk about it, extreme hot and extreme cold. So when we go to Mars, actually we in our work we pointed out with Curiosity's work. Curiosity is a rover on Mars which has detected methane on the planetary surface. Methane is a molecule. So what we were able to get convinced out of it was a methane can come out because of a metabolic activity. So is the phosphine gas, and we know recently Cardiff University of Scientists, which became a big news in all over YouTube and all over social media, that there could be life on Venus. Venus has a very interesting atmosphere. Mercury is too close to the sun, so its temperature is around 400 odd kelvins. Well, Venus is next to Mercury. Its temperature should be colder than Mercury, right? Instead, it is doubled, almost 730 Kelvin. The reason is it has an atmosphere which interlocks the temperature, and the radiations is trapped inside, so it becomes much hotter. So on land, you can't expect any of the life forms to exist. But on the upper atmosphere of Venus, there is a possibility. We call it as stratosphere. We know aeroplanes fly in troposphere. Above troposphere, you call it as stratosphere. So above the aeroplane part. So that part, we have detected a phosphine gas. So there is a search going on right now whether there is any life form existing in the upper part of the atmosphere of Venus. For this, me and my team, we work with Indian Institute of Astrophysics. We have a balloon research group. We use helium balloons, and we send these helium balloons to stratosphere. This is not an easy thing. This is the cheapest way to go to space, what we are doing right now. So because of funding, and we have to take permission from ATC, air traffic control, from Bangalore, because we launch from the Bangalore airport. So we have a launching station in Hoskote. It's called Crest Observatory. So from there we launch this balloon. We send it to stratosphere, and we try to collect some biological sample. We want to first search in whether there is life exists, any microbial life exists on our Earth's stratosphere. So that is still an open question. We still have not detected anything, and launching is not so easy. We use helium gas filled balloons, and we launch them, and we have some engineers who do build certain things, and we do launch them. And we got a launch window for midnight 2:30 to 3:30 to launch. And if it rains, it's our bad luck, so we have to wait. And when we launched for the very first time, it went and fell in the Arabian Sea. And some fishermen, they had sold everything and brought us the empty box and gave it to us. And then we understood our mistake. Then we put a price tag on top of it. Whoever brings this safely without selling anything, we will pay you some money. So with the government symbol and everything. And some people, when the second launch happened and it fell, some people thought it was a bomb from Pakistan, and they started beating with stones, bricks, and whatever is possible. And recently when we launched, it went from Bangalore, and it fell in Tumkur, some open area, agricultural field. And with GPS coordinates, we went and tracked, and first time we were able to track some kind of sample out of it. So right now our work is going on at Indian Institute of Science to analyze the biological samples from the microbiologists. So these are the kinds of works right now it's going on in our group, in our research group. But there are many research groups which are doing these kinds of experiments to search in stratosphere, and because Mars has a similar stratosphere, so there could be life on Mars, extreme lives. So if first we have to find and figure out whether there is life on our Earth's stratosphere. So there are various aspects and in checking out the microbial life. The ones what we worked on recently was with respect to a biological aspect was we were talking about rocky extremophiles, the microbes which can survive only with the presence of rocks. They don't need oxygen, they don't need anything else. We have such microbes in our own planet Earth. So the two names of those microbes are Crucochydiopsis and Acarospermo. It's okay if you don't remember the names; they are fine. These microbes are sent to International Space Station (ISS), in which we have a Russian module where we have something called as Expose S laboratory, Expose X laboratory. There what they do is they try to expose them to harsh space conditions. This is where tardigrades were able to survive for 12 days. So they want to do this, so this experiment is going on right now. We are waiting for the results. So this and what I did was I took these microbes and I checked whether they can survive on any other exoplanets, as I have this habit of doing. So I did that, and for my surprise, we were able to find potential planets for these rocky extremophiles, because we have a lot of rocky exoplanets.
Mhm.
Gas giant, we have two types of exoplanets. One is called rocky exoplanets. Rocky planets are basically our inner planets like Mercury, Venus, Earth, Mars are rocky planets, whereas Jupiter, Saturn, all these are gas planets, and Neptune is an ice giant. So these are the planets we have. It is very hard to survive on gas giants because there is no land to stand, and it is filled with poisonous gas. So we don't see a point in checking life inside those gaseous planets. If you go to Jupiter, you don't have land like this to stand on Earth. So you'll be floating. First of all, you'll be teared apart because of the gravity. But if you go there, there is no land actually. So that's
I
how
see.
Jupiter looks like.
The funny thing is that I don't know, but we as humans always think of life on other planets breathing, eating, and walking and surviving like that.
Yes.
But if we think apart from our ego, if we are not so egoistic as
Yeah.
species, I mean, there may be life with anything possible. I mean, they must be loving that poisonous gas on Jupiter, and we just don't know that. Okay, these are living organisms, because for us, living organisms have to use energy to do some work. So work done is
Yes, that's
without
true.
a machine is like a
Yes,
species.
exactly.
So
This is a big debate. Actually, what you are asking is a very fantastic question, because this is a big debatable question. The reason is everybody says there is different, because there is a notion right now there could be a methane type of life form in Titan, which is the second moon of Saturn, where only methane rivers and methane floats, everything methane filled stuff. So there could be a life where which could just survive on methane, as you just said.
yeah, a methane must be their ice cream. Who knows?
Yeah, who
That's
knows? Who knows? We never know. Yeah, but what we do as people from science, when we do an hypothesis, it should be based on an observation. The
Mhm.
only thing we observe as science people are, we know life exists on Earth, and this is the recipe. It should be at the right distance from the sun, and sun is an yellow type star. It should be around an yellow type or a cool star, and it should have enough time to evolve as a life form,
Mhm.
and then we can say life exists. This is the life we know that we have observed. So keeping this map in idea, we are following this map. So that's
Um,
the hypothesis we are following.
One thing I mean, there is one astrobiologist. Her name is Sarah Walker,
Yeah.
and she is running after phosphine in other planets'
Yes.
atmosphere for very long. Why phosphine? Why is phosphine so important to find
Yes. I'll
or to
just
determine that there is life on other planets? As
I
you
was
said,
talking, yeah, as I was talking about Venus, this was the main thing.
yeah.
Phosphine is the main gas we found. Actually, phosphine is found in industrial waste,
Mhm.
and if there is microbes metabolic activity, phosphine gas can be found. Otherwise, there is no other way to find phosphine anywhere else, because we have not found phosphine anywhere else, and we have found phosphine only in our industrial waste and microbial metabolism. Other than that, nowhere else phosphine is found. So it is a very important compound that we pH3 is very important for us to know whether life exists on other planets also. That's why we look for something called as biosignature gases. We look at the spectrum and determine whether that gas is present in that planet or not. We do take the spectra of those things. And
Talking about spectrum, I want my viewers to know what spectrum you are talking about. It's that just that where
okay.
every planet has an atmosphere
Huh.
and it refracts
Light.
the light from its own sun. And
Yes.
from that,
We take
what
the
do you call it,
spectrum
wavelengths and difference in wavelengths, you determine
in
what
the
chemical
spectrum.
is in that.
Yes,
I
exactly.
mean, that's amazing. But
Yes.
my another question will be that as you said that phosphine is only through industrial waste and some microbes, not from
Yes.
human life itself.
Yes.
Then why is it searched as a indicator of human life on other
We did
planets?
not say
Not
human
human life, but
life.
actually just life.
Just life, yeah. Yeah, just life indicator, because this is the only thing we have detected so far. This is the only progress we have made so far. So that's the reason we are tracking the phosphine thing as a very important aspect. We have many more ways of looking at things. We look at something called, other than biosignatures, we are trying to look at advanced life form with technosignatures, whether there are any technological debris left for us to search, whether there are any, we have GMRT, giant magnetic radio wave telescopes in Pune. They
Mhm.
can hear sounds from outer solar systems. Okay, so these people are very sensitive. GMRTs are, there are only 8 astronomers, radio astronomers in this country right now who are using GMRT, and I'm happy to be a student of one of them. And what they do is amazing, because magnetic field is a very important aspect of a planet, because magnetic field of earth protects us from high energy cosmic radiations. None of we will take those things as granted, but once we go outside the earth's magnetic field, we die by cancer. So NASA had asked for a project, space project. It was an open project based to begin with, and then it became university based projects, and my university was one of them, and I was one of the person who worked on it. So what we did was, we were supposed to design a space suit which can produce magnetic field around it.
Mhm.
Okay, so what I can't tell you the entire details as it is classified, so I can just tell you this much. So the suit, what we did was, we took a 6 feet tall man, and we know something called a solenoid exists. What a solenoid is, you have a pipe, on top of it you wind some coil, and you pass current through it, it gives you magnetic field. It's a simple principle. So we took a 6 feet tall man, we shielded them with an insulator, and then on top of it we know a strongest conductive material which is called as CNT, single volt carbon nanotubes, and it is produced by one of my friends in Nopo in Bangalore. He has a nano power industry, so he usually supplies carbon nanotubes to space. So what he not, when I say space, space cables, what they are working on NASA, so he provides those CNTs. So you can wind up those CNTs and pass very minimal current. I can't tell you the numbers. So when you pass those current, the magnetic field is induced around you, so you are protected from high energy cosmic radiation. This was the idea we work for. Us, we are still, we want to protect ourselves from the cosmic radiations, so we want to find a planet where magnetic field is sustainable. Right now Mars does not have magnetic field, so which is a very dangerous things. So we want to, Mars has many challenges, because in order for us to become multi-planet civilization, not water is not just a problem. We can get water from Mars. There are polar ice caps. There is a two proposed ideas, one from NASA and one from Elon Musk. Elon Musk wants to nuke the poles or polar ice caps in Mars, and where NASA wants to build a huge mirror and reflect the sunlight to the pole so that it gets naturally melted and the water flows in Mars. Yeah, and Mars has a very thin atmosphere. Okay, our Earth has thick atmosphere, we have clouds and we have rain. Mars has very thin atmosphere. So instead of polluting Earth, if we pollute Mars, we have a chance of getting rain in Mars. So all our industries should be shifted to Mars from Earth.
Yeah.
Then we have a very good future ahead of us.
I have seen one documentary of Elon Musk's plan to terraform Mars.
Yeah.
Actually, terraforming is a term used uh, by scientists like
Yes.
Madhu here, and it means that what will you change in a planet to make it habitable like Earth or as
Yes.
close to Earth? And their plan is that first they want to nuke the polar caps of Mars so that water will be there. They also want to burn a lot of fuel on Mars industries or however, and because of these carbon emission, these carbon emissions are, what do you call it, greenhouse gases,
Yes,
and that's how a layer of greenhouse gases will
atmosphere.
come around the atmosphere of Mars, and it increases the temperature of Mars
Yes,
also.
exactly. Mars is little colder compared to Earth.
Yes.
Our surface temperature is around 273 Kelvin. So Mars is around 220, and the temperature of Mars is still a debatable one. So it's quite cold, colder as compared to Antarctica. It's quite cold.
When we talk about life, do you ever think about life of on other planets like plants on Earth, or is it just life
Okay.
like what we are? What
That's a
about
very
plants?
interesting question, and you have asked me in the right way. So the thing is, when we talk about plant science, okay, plant has to have proper soil. So soil is the main ingredient that we know of, and you would have seen the movie Martian.
Hmm.
Mars soil does have the capacity to grow plants, but we need to give the right nutrition value to it. So we have to look at only rocky planets for such matters. So we know gas giants plant can't survive unless we don't know the undefined ones, and ice giants also can't grow plants unless we don't. Again, I put that disclaimer, unless we don't know the life form that we have never heard of. And if there is life, it should be on a rocky planet, and it should have soil. Soil is the main ingredient what we are looking for. So when, but we don't have the technology to look up whether there is soil on exoplanets. Our current technology and science has not developed enough to check whether there are soil or any minerals present exactly for the needs of a plant to grow. So we are still lagging behind. Maybe we will catch up as the time grows up.
I mean, this is another question which comes to my mind sometimes at night before sleeping.
Okay.
I don't know. I don't know the answer. I just want to ask you. You are a scientist. Probably you will find out the answer for it in future. I have never heard a theory of evolution of plants. I have always heard a theory of evolution of man or
uh,
humans, that we started from a fish, amoeba, single cell organism, and then we
yes.
became this. But for plants, nobody says anything. If you find out, just please send me a mail how it happened.
Yeah, as we said, it should have the right ingredients. Right now, we know what a photosynthesis is, how the plant starts with a seed, and all those things. We should know the plant physiology. Then, but the whether the egg came first or the chicken came first is an open problem, right?
Hmm.
Similarly, whether the seed came first or the plant grew first is an open problem. So it's still a philosophical question right now. So when we tackle with science, we still don't know what exactly started with. So we still keep it as an open problem or a philosophical question right now.
I see. It's good that you talked about philosophy. The point is, in science, everything which we use, force, momentum, inertia, impulse, induction, whatever, it has a definition.
Yes.
Now, you are searching for life on other planets. What is the definition of life in scientific community?
Oh, very nice question. See, when we talk about life, so we had a debate. There is a debate in SETI, Search for Extraterrestrial Intelligence. What they do is, if an alien comes away right now, maybe
Mhm.
in an invisible form, we don't never know. How will the alien differentiate between we are the living organism and bus is not a living organism? Because bus moves, we move. Bus makes sound, we talk. How does it differentiate us from the machines? So the most possible answers is, anybody who is trying to find a form of communication is said to be having life. So intelligent life, when I talk about intelligent life, it should have a way of convincing through communication. So it should find a way, get try to communicate. The person who is trying to communicate with you is the person who is trying to be a living form according to the intelligent life form. But when we talk about like an elephant or any moving organism, a moving train, then it is very hard for those animals to communicate with the aliens. Just like we don't understand the language of elephant right now. Okay. Similarly, even aliens will find it hard to find because the only way once the alien comes to us to define something as life, it needs a language for communication. So that's how everything starts, because we are made up of biological material. They need not consider biological material to be the life form. So there are different aspects in which you can counterpart this question. So it's a very interesting scenario. Still, the only way we can recognize life is through communication. Communication is the key.
I see. Then I have a very not bad, I say, I mean, a utopian scenario that what if aliens come maybe 1,000 years later, 200 years later, when we have talking robots with a little bit of things like us. They can talk, they can have a conversation, and then the aliens will be very confused that they are talking to a human, or for them robots are also communicating. So do you think that is it benchmark which is acceptable for very long?
No, this benchmark is not acceptable for very long once the robot starts talking. So communication may be a key, but if we are handling those robots, if we are the ones who we say we are the ones who are handling the robot and we communicate that part to them, then it should be fine.
Because Neil deGrasse Tyson said, someone asked him that, what do you think, will aliens communicate to us, or they will conquer us, or whatever, just like science fiction?
Yeah.
And Neil deGrasse Tyson said that if aliens have to research about life on Earth, probably they will go and research on ants rather than humans, because ants are the most productive creatures on Earth, and they have all their civilizations, they have everything. So I think that this all things are quite weird but very interesting to think about, and people can make their own theories. I am a stupid person, I do not know anything about, but I have my own theories just because they are interesting.
Okay.
um, but before I go into more of weirdness, let's go back to the BE stars. Tell us
Okay.
about B stars, because after that I will talk to you about multiverse,
Okay.
and I will want to talk to you about UFOs too.
Sure,
So,
sure.
but first, more important stuff. Tell us about B stars. How did you start with it, and what is the significance of researching on these stars?
Okay, so B stars are, as I told you, they are classified from, we have different ways of classifying stars. So we start with O, B, A, F, G, K, M. So these are the types of stars we have. The way we remember is, oh boy, a fine guy or girl, kiss me. So that is the acronym. So what we do is, O type is a hot star and M type is a cold star, and B is also a hot star, and our G is a G type stars are sun like stars. Okay, our sun is a G type stars. It is based on the color and temperature. Okay, this classification is done. So our B type stars are very hot stars. Okay, they are bluish in color. So they are huge suns. They are massive stars, very very massive, and their lifespan is very small compared to our stars. So we look at these planets, which are these stars, which are very huge, and they have a habit of omitting disk. They omit disk like Jupiter, and the disk appears and disappears. Nobody knows from last 150 years how the disk appears, and when the disk appears, and when the disk disappears. So this is an open problem for 150 years. So this was first discovered by Father Sachi in 1866. Okay, the famous astronomer Father Sachi. Till now, nobody knows the answer. So it's an open problem for everybody, and some theories, some weird theories are also coming out of this right now. Some people want to connect with the time dilation part of Einstein's relativity, where we talk about time dilating. So is there any connection between the time dilation and this disk? So that is still a theory right now, still not a concrete one. So this is an open problem. What I am trying to search here is with respect to age. At what age does this phenomena occur? So I'm looking at stars with age. In order to find a star's age is not a joke. So what we do is, we can't find stars which are singly pointed out. We have to look at stars inside a cluster which
Mhm.
has a defined age. The way we calculate the age of a star in a cluster is through something called as HR diagram. Hertz-Russell diagram. Looking at their brightness and temperature, we plot a graph and we recognize those evolutionary states. If you have done very basic study in the chapter called Universe in your class 10, you would have heard of this diagram, HR diagram, where the diagram will have a diagonal, and then there is a turn-off point where the stars are in the main sequence, and then they get evolved to red giant phase, then super giants, then we have white dwarf planets. So the evolutionary phases. So we define those evolutionary phases. So I want to see whether these stars are on the post main sequence region or on the giant phase. When we talk about giant phase, whether they are too huge and they are about to die. So whether they are in that, when they are in the death stage, whether I'm looking at old stars, okay, because previously young generation stars are studied by many scientists. So I'm looking at the older age part. Nobody had searched there. So what I did was I wrote a proposal to Bangalore Observatory and Himalayan Chandra Telescope. HCT has a unique way. Himalayan Chandra Telescope has a unique way of taking the spectrum of an entire. We have something called a slitless spectra. You would have heard of slit spectrum. This is something called as slitless spectra, which is a new technique developed by our team through HCT. So we take one single shot of a cluster and we will be able to get some dispersion lines. And we go on each star. We have a huge software and coding to do, and then we use IRAF to check for an emission line, H alpha emission specifically. H alpha emission is basically hydrogen emission. We look for, you would have heard of Lyman series, Balmer series, Pascal. You would have studied spectral lines in your class 12, if you have studied class 12. So the Balmer lines has this unique line called H alpha in emission. And if the H alpha is in emission, then we call the definition of B star itself is a very interesting one. The definition starts with the name called as working definition. It's a working definition when a B-type star has or had a H alpha in emission. When this H alpha is in emission, we say the star has a disk. When the H alpha is in absorption, we say the star does not have the disk. So this is how we detect the presence of the star's disk of this B-type stars. Okay, so BE stars are these stars which has particularly H alpha in emission line. So we were looking whether these lines are seen at above 100 million years. So I have looked into more than 78 clusters which has many stars. So I have looked into each of those stars, and we were able to find around 15 stars which are BE stars, because we were expecting a small sample. So we did get a small sample, and we want to comment whether this BE star phenomena is connected to the age factor or not. So this is the work I'm doing currently, and which I'll be finishing in this year.
I have one question. You
Yeah.
said that a disk comes around that star
Yeah.
periodically.
Not
Right?
periodically. We don't know the period. What frequency it comes, we don't know.
I see. So if there is a constant disk around a star, then it is called a B star, or
There is no such type of stars according to my knowledge, because when we talk about constant disk, we talk about a star formation region. When they are young stars, the gases are surrounded like a disk, and they tend to become a proper hydrostatic equilibrium star. But initially they will all have disk. That is quite obvious. But the star which is evolved and having a constant disk is not heard of. So this comes and appears and disappears, and sometimes it happens through years for appearing and disappear. Sometimes it happens for days, sometimes it happens in hours. So it is quite a tricky notion when it appears and disappears.
I see. What if every star is a B type star, and it is it is in the point of some point in their life, like our beard grows white, probably they become a B type star, and we just cannot see because there is so much of time taken from
We need
one
to know
star to
what is
another.
that beard growing time. So that is
Yes.
a question that is not solved for 150 years. We don't know when it comes and when it disappears. And many people have done a lot of work in this area, because 150 years of work is not a joke, and it is done across the globe. And we have almost every country has some 3 or 4 BE star groups right now.
Hmm.
So and everybody is researching on this. and some people think something big is out, because we are working so much hard and something has to be there. So until we find a solution, I don't know where exactly we are going to apply this, or where we are going to do this. Usually when we do pure science, we just follow the curiosity. When it comes to applications, we call on the engineers.
I see. So tell me, what aspects do you look through, what through what aspects do you look at a B star? I mean, do you look at that? Okay, maybe the poles are too different, and maybe the magnetism at those poles is too high that it pushes the atmosphere out for some time, and then reaches
Yeah, there are many
equilibrium.
theories. One is fast rotating; it rotates very fast. But that alone does not conclude the answer for that. Another way of explaining this mechanism was, as you said, magnetic field. Not all B stars have magnetic field. And one more aspect was, one more nearest answer was radial pulsation. Radial pulsation, it pulses out time and now again. So that is one of the answers, but that is not a concrete answer. And one more way, or one more answer was whether whether it has a binary companion, binary star, two stars, whether it has a binary companion. But the problem with the binary companion, all B stars are not binary in
Mhm.
nature. So all these theories had to be removed. Only the two theories that has some level of understanding, proper level of understandings, are fast rotators and the non-radial pulsations.
So the point is that you can find the same phenomenon from every BE star, but
Yeah.
you cannot find the same reason for that
Yes.
occurrence, and you have to
Exactly.
find that one
One that
reason
has
for
to be
that.
same with everything.
I see.
So that's an open problem till today for 150 years.
Yeah, sometimes when I meet and talk to people like you, I get a little bit of jealous. You know why? You are the people on whose work the future generations will work and find out the solutions, which will be taking us to type 1 civilization somehow. I don't know, but you people are very important, and these all researches and out theorems and whatever comes out
Actually,
of
I
your
believe
work.
everybody's work in their own way is important in this world, because everything happens for a reason. And even if a person who is trying to build a rocket nozzle, only the scientist need not take all the credit. Even the person who is pouring fuel into that rocket nozzle should be considered important, because
I totally agree. I am that person who pours fuel in from the nozzle. So I know I am very important. No, my point more importantly was that these studies take a lot of time, sometimes
yes,
life of the whole life of
yes,
scientists, yet they do not find a solution.
answers. Yeah.
And once after 15, 20, 100 years, people go back to that theorem or that theory,
Yeah.
and they start using it. I
Yes.
mean, just take an example. None of your calculations would have been possible if there was no theory of relativity or no Schrodinger's principle or whatever. These things will not be possible, but
Yes.
they found, maybe they showed the future
Yes,
scientists a path.
is based on the literature survey. So we credit every scientist who has passed behind us. See, if there is no literature survey, no international publication will take you seriously. So
Yeah.
they want to know that you have done thorough literature survey. That means you have understood the ideas of all those scientists and you have acknowledged those scientists in the reference section, and then you go ahead. That's the most important thing in research. There is no I in research. We always say we in research. Okay, because it's not one person's idea, it is multiple people's lifetime hard work that will come out as a paper finally. Even though we might have just added a small dot or a bump into that work, but in order to look at the entire cycle, we all have to hold hands for centuries.
Exactly. I mean, you are the perfect example of what evolution is. I mean, how we evolved from Galileo to till now. It's a real life evolution which we can see in real time when documented. Um,
Yeah, Varun.
yeah,
Yeah, even I was noticing this particular V word from Madhu,
Yeah.
and I was just thinking that there are different space agencies in the world, whether it is related to US or India or maybe
Yeah.
Australia and Russia.
Yeah.
So uh, there are many researchers who is doing different kind of research, and many telescopes are available into different region of the world, and maybe Hubble, or you told about this TESS, and I was
Yep.
also reading about this James Webb Space
Space
Telescope
telescopes.
going to launch in
Yeah.
maybe in November 2021.
Yes.
So how you coordinate means how all agencies are coordinating each other, how you all are sharing informations. You told that okay from maybe from that one Pune, you told about JMRT, right?
Yeah.
So you are looking at some direction, and maybe a person sitting in US, a scientist in US is also looking towards the same direction. So how you share the information as
Okay,
a
that's
common
an
person?
excellent question. That's an excellent
Why?
question.
Why I'm asking?
Communication. How do we communicate? We all
Because
have databases and literatures. We have a common database. The most commonly used one is NASA ADS. Right now, right now we are in a golden age of internet. We are all happy. Previously, people used to use libraries where to see whether these people have done. If the same work is done, you have to acknowledge that work. It's compulsory that you do that. So if there is some kind of repetition in the work, one person's way of interpreting it will be different from the other person, and we rarely get overlapping of ideas because we are all unique. 90% of the time they don't overlap. There will be 10% there is a chance of overlapping with the same ideologies.
the same, I have another question on the same line. See, for example, NASA is having its Hubble, and a few more telescope they are launching, and some other countries also having their telescopes, in particular their country only. So how this, if some information is, NASA don't want to doesn't want to share with any other country or any other scientist. So how you get those information from, if Hubble is doing something, or maybe
Then we have to launch our own telescope. That's the only way. If the information is not given to us, then we have to do our own work. So we say none of the formulas are given just like this to us. So everything has a price for it. So whatever right now we are doing for research in science, everything is open to public. So everything is transparent and everything is with respect to databases. And we have all the databases. For exoplanets, we have exoplanets.eu, exoplanet.org, we have NASA, and we have many others. And even many people were telling many countries have telescopes, optical telescopes in space. Why don't we have one? That is a question that many of us do ask. But we have excellent ground-based facilities. I'm gonna say one of the high-class ground-based facility, and we are involved in a bigger global project called TMT, a large telescope which is about to be built in Hawaii right now. So it's collaboration of many countries, and India is playing a huge role. And my guide is basically the director of Indian Institute of Astrophysics. So she is the one who is heading that TMT group right now from India. So what they are doing right now is it's about to be launched, and whatever information, as you asked the question, see, not everybody is gonna look at the same object at the same time. So what we do is, because our whatever sky we see in US is not the same sky we see in India, because Earth is rotating. So we all look at different parts of. And I said about the Orion constellation. If you go and look at the same Orion constellation in Australia, it will be ulta. It will be the opposite direction because of the South Pole. So mirror image, whatever you see as the sky right now, it will be the mirror image in Australia. So it will be quite weird to look at it, but yeah, that's how you see. And whenever somebody is about to use a telescope, they have to write a proposal, research proposal, why they are doing what they are doing and everything. So those information will be available to everybody right now. So based on that, not many people will be looking at the same thing for the same reason. They will look, maybe they might look at the same thing for a different reason. So that's the reason we are not overlapping so many ideas as we were about to do it previously in many decades ago, before internet, before the age of internet.
okay, yeah, Varun. Yeah, Varun.
Yeah. One point, Madhu, which came to my mind was, I mean, I think I told you before we started recording this podcast, is this multiverse theory.
Yeah.
So there is, as I said, I will get into weird stuff too. It's
Yeah.
not weird. It may be not weird in future. We may find out it is not weird. It's just what it is. But there is a theory which is called a multiverse theory, and according to that theory, it says that exactly at this moment, in some planet, in some universe,
Varun will
I
be
am still taking an interview with you,
okay.
and it is going parallelly.
Parallel universe. Okay.
So
Okay.
explain to me and my viewers what is this multiverse theory. And another thing which I want to add is that how is it connected to that string theory, because string theory is still not widely accepted. Some people
Yes.
don't think
Believe
that
me.
okay, it's a viable theory, but
Yeah.
it is the only theory which is maybe connecting the classical physics to the quantum physics. So how is it?
Okay. We have something called as theory of everything. Okay, so we have different mechanics, as you said, classical mechanics, quantum mechanics, relativistic mechanics. We still have quantum chromodynamics, quantum electrodynamics, quantum field theory, everything, all these aspects, and quantum loop gravity, many things we have. When we talk about we have four forces, four fundamental forces: gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. Is there a single elegant equation where all these four forces can be explained with one simple equation? That's the open question that has been not solved till today. Okay, we are able to put in nuclear, strong, weak, and electromagnetic forces together, but we are not able to put gravity in it. Gravity is not so easy. When we say put it, it's not in a bucket. So what we have to do is through mathematics, very hardcore mathematics. So we have some brilliant work in the process of string theory, because in order to address this big question. So on the way of addressing this big question, we call this as M theory or string theory in layman terms. So what we started was just a beautiful mathematical model, very beautiful. When I say we have come up with some mathematics which we have not heard of, I have a friend who is a string theorist, who is a doctor from Indian Institute of Mathematical Science. He was my classmate. He is one of the person who works on this area. When I open his paper, research paper, I don't see any English. I see only math. Okay, so that's how those papers are.
Can you tell me his name? Maybe if
Uh,
he is agrees to talk to me.
Madhusudan Raman, Dr. Madhusudan Raman. He's right now doing postdoc at TIFR, Tata Institute of Fundamental Research. If you want, I can
Yeah, I would love to talk about string theory.
sure. Yeah, he does work on that area, and most of the time we find jealous how he could conquer that, and his life story is different from mine. Yeah. So coming back to this multiverse part, connecting in layman terms, I'm just talking with respect to layman terms. I'm not using any complicated words. What I want to tell is, if there is a universe, so we think each of this universe is a bubble. Okay,
Mhm.
each of this universe is a bubble, and these are through mathematical bubbles, hypothetical mathematical bubbles. We don't know whether they exist. When somebody asks your address, whenever somebody asks my address, maybe I'll tell my address, not the real one, a fake one. So to begin with, my name is Madhu Kashyap. I stay in Gandhinagar, random one, and Gandhinagar is in Bangalore. And when I say Bangalore is in Karnataka, Karnataka is in India, India is in Asia, and Asia is in the world map, Earth, and in our solar system and the neighborhood of the solar system, and I'm inside the Milky Way galaxy, and I'm in the universe. Okay, this is my address till universe. So when we talk about multiverse, this is the whole thing should be there in the passport if you're going to a different universe. So this will be our passport address. Now you want to go with this passport to some other universe. How do you go? First, do you know that such kind of universe exists? Mathematics says yes. Some of the mathematical models do say yes. We say there are multiple bubbles, random bubbles, just like gas molecules randomly spread. Each of these bubbles is a universe, single universe. Okay. So in order to penetrate from one bubble to another bubble, you need to travel very fast. Okay, as fast as speed of light, as the recent comics of Flash. Okay, TV series Flash. So you have to go very fast. So you have to reach the barrier and jump. We have something called as quantum tunneling effect. So you have to go through the tunnel and go to a different universe. So such kind of multiverses exist. So I'll just take the example of the Flash TV series, which is known to us. So what Flash does is, in this universe he is good. Some universe he might be evil. Some universe he might be not a Flash. Something else. So there are different possibilities. So this is one theory. Okay, this is the way multiverses exist, and we know, if somebody is, once we know about multiverse, they won't say I love you any more than anything else in the entire universe. They say I love you more than anything else in this multiverse. So that's when we reach that world. Okay, that is the reason, that is the kind of life we will be living when once we know multiverse is real. And once this multiverse is known, then we look for their parallel mirrors. So we think each of these bubbles has a mirror parallel to it, and in order to pass that dimensions, we may end up having two similar bubbles also. So we might end up from one to another. Imagine this: each of these bubbles are drunk. Imagine each of these bubbles are drunk, and you have seen Jackie Chan's drunken movie thing. So you keep on, when you're drunk, what do? You go and hit one person, another person, or you fall on the road. So just like gas molecules bombarding with each other, and we call it as drunken master slide or Brownian motion. So similarly, these things can be looked into such kind of aspects as well. So once you collide with those molecules, you might come up with a different universe. And if you, for that to happen, in order to access such, you have to travel very fast. So that's the current simplest layman version of multiverse.
So, how did this multiverse theory comes into picture in the first place? Was it discovered or was it invented?
We won't use the word discover or invention. It was totally mathematical modeling.
Hmm.
It's still a mathematical modeling. So until we detect it, we can't say whether it exists.
I
So
see.
still people are skeptical about whether they exist, but the math is saying yes. Math is a language. It's not English.
Yeah.
It's not Kannada or Hindi. It's the
Yeah.
universal language. So if math says something is there, then we have a reason to believe, and we are having a lot of ways of trying. We are trying to build certain things to detect this. Still, they are all in the proposal states. So we can't go ahead with those things right now.
I see. So, these many world theory or multiverse theory, uh, do you think, as a scientist, not like me, but as a scientist, do you think that these theories take a lot of attention from the real work which the scientists do? Because these theories are okay, they are outliers, but okay, right now we want to fight this climate change, and we want to check the population, and we want to find the nearest planet which will help humans survive in future.
That way, what Elon Musk is doing is right. We know a planet neighboring, and we have technology which needs improvement, which can help us to go to Mars. So we can become multiplanetary species, hopefully in our lifetime. There is a possibility because it has given us a lot of hope.
Mhm.
And we have reusable rockets right now, which has brought down the cost as well. So there is a possibility. We never know. Fingers crossed, it might happen in our lifetime.
I see. And the final segment of this podcast should be with most interesting one. I for me, not for you, but for me, it's alien and UFOs. And in past 2 years, there are now various confirmed reports and confirmed sightings from Pentagon in United States. Also, that they found they have footage of UFOs called Tic Tac, or there are what else, what was its name, I forgot, but there were many alien sightings. So what do you think, do you have you started believing in aliens somehow, a little bit, 10%, 5%? And what do you think, why are they here in the first place, and how did they come here? Maybe
Okay.
that was with a better question, because as you said,
So
it takes billions of light years to travel from one place to another in solar system. So how is it happening?
Okay, first of all, the full form of UFO, unidentified objects, means we don't know those objects.
Okay, now I will change then. I will say UAP. Now it is called unidentified aerial phenomenon. It's not.
Okay. Okay, unidentified object. UFOs basically, actually recently Pentagon released a file and confirmed UFOs a few years back. So when I saw this, I got more emails more questions than anything else in my entire life. Okay, I got more than 1,000 notification emails. I remember that day very well because all over the news it was overflowing. So what I did was I went to the source. I have a professor, a retired scientist from NASA. His name is Dr. Ravi and Marga Saham. He is the one who sent Kalpana Chawla and Sunita Williams to space. So I called him up. We met him. I met him in US when I was in US. I met him in NASA. So we were going to Germany for some reason, and we were talking about this. I asked him this whether UFOs files are real. He did say one thing. This could be because COVID is going on right now. They want to get world's attention right now here. These are unidentified objects. Basically, these files cannot be explained. We don't have that kind of technology which can travel so fast and disappear. It was just like Star Trek. So the shapes were like in the saucer face, and it had some nozzles coming out of it, just like a starship. So the hype was very much in there during that time, and it happened in 2020, and monoliths started coming up everywhere. You would have seen monolith reports everywhere.
Right.
So these two things got connected, and people started wondering whether these are markings of time and coordinates in space, whether these things. So there are so many conspiracy theories, but coming from the scientific point of view, we just say they are unidentified objects because we don't know the answer yet. So whatever data we have right now, it is not we are not able to give sufficient answer for that. The reason is we don't have enough data, sufficient data to say they are aliens. And whatever sky we are looking at through telescope is not the present sky, it is not the current stars. They are all old. They are very very old. Means whatever sky we are looking at, they are light years old. So the sunlight what is touching my skin right now, how old do you think they are? Do you know how much time it takes for the sunlight
Yeah,
to reach us?
8 minutes, some
Yeah,
seconds.
8 minutes is a natural answer, but those photons are not 8 minutes old. They are born inside the core of the sun, and they have bombarded. They have gone through that drunken phase, a random walk
Hmm.
with the Brownian motion. They have taken 1,096 years to come to the core, from core to the last part of the atmosphere of the sun, and then take 8 minutes to reach our skin. So, sun that the photons that is hitting us is very ancient. They were born when your great great grandfathers were walking on this earth. So
Hmm.
they are not born now, they are very old. So the photons what we are looking at, the sky, the stars are much older than the sun. So those that is the like we are looking into the past. We are not looking at the present sky, we are looking at the past. So those are very old data what we are getting right now. This is what happened few light years ago, what we are predicting. We say the
Correct.
star is Andromeda is some light years away, right? So we say that many light years we are looking at the Andromeda, how it was some light years ago,
Hmm.
not the current. Currently, what has happened, we don't know because the light has not reached us. Light is the only information we have. So light is still traveling at 3 into 10 power 8 meter per second, fast, but still it has not reached us. So we are waiting for that light to reach us to give the information of the current sky. We are always looking at the past.
Uh, there is a theory to explain these speeds of UAPs or UFOs. Uh, Suddenly, I started supporting this UAP. I always supported that term UFO, but as soon as you said that they are unidentified, I like aerial phenomenon better than. Uh, the point is, they say something about gravitational propulsion or gravity propulsion, something like that. That these aircrafts are using gravity as a form of propulsion because whoever, I mean, Commander Fravor. He said that I mean, he's a pilot in Air Force in U.S. Navy, and he said that it was not making any sound, and there were no exhaust and fumes out of that UFO.
So they just
So
disappear. Yes.
and they just disappear, and within less than 1 second, they move from 60,000 feet in the sky or
Mhm.
meters in the sky to 5 meters above the sea level, and
That's huge. Yeah. We don't
people
have the
are
technology to believe that.
so,
Yeah.
yeah, and we do not have even the material to
Do that.
sustain such fast speeds and temperature.
Exactly. Exactly.
So that's why I truly believe in UFOs. I mean, there are aliens. Maybe there are not real aliens. There are their robots, but someone is there. Something is there. Otherwise, it cannot
Actually,
be explained.
there are some ancient theories. There was this experiment done on some tribe in Africa. So what they did was they went on an aeroplane and took some cargo food in them, and they dropped it from the sky on these people. The food was delicious. They enjoyed it. They took 1 or 2 months break and then went ahead to check what they are doing. They had made a symbol of aeroplane and they were praying for it. So, whether whatever the definition of God, whatever we think of, this is one of the theories, just a ancient theory. It's not a scientific basis theory. This is a documentary done by the History Channel. So, the according to the question is, did we pray because we got something from the sky, or somebody dropped something from the sky, and we started praying for it? We never know, because there is a lot of theories and searching going on in that particular area, whether it's a possible reason for that.
Yeah, I mean, the question about God is again a very sensitive and controversial question. But when you think of universe, the way you think, and the way in the it is described in the books which I have read,
Yeah.
I think that the notion of God will be even more weaker as we go in future centuries. I guess so.
Yes.
So let's see.
So there might be a different angle to explain certain things.
Hmm. I mean, whatever we do not know, we call it God. The God particle is an example in scientific
Actually,
community
God
also.
particle, you spoke about God particle. Large Hadron Collider, there's a big tunnel from Geneva to Paris. There's a huge, no, Geneva to France. So there's a huge tunnel, 27-kilometer wide. So what they do is they take a hadron and they collide, bombard, and they'll make it like a big bang. So what this particle does is particle is conserved, just like matter. It cannot be created nor destroyed, but it can be
Yeah.
transformed. So this particle was created by man. So we call it as God particle because we created it. And actually, it was called, the name God particle came was because we could not find this particle initially, and it was named by the author. There was one author who named it in a book as goddamn particle because he could not find it. So the name came as God particle. So that's how the name God particle came into existence there, because of the book. And when there is a collision, we have this new thing called as antimatter. Okay, so what this antimatter does is 0.25 grams of antimatter is sufficient for an explosion of Hiroshima and Nagasaki. Just a 0.25 grams, that much powerful. So we are able to extract this. Maybe in the future, if we are able to control this, maybe we can use this as a rocket fuel and go to different planets. Maybe this is the way we use sustainable energy to travel. We never know.
Yeah. I mean, the fuel solution maybe we can find, but the material solution, I still think that we have a long way to go. Or maybe
Yeah.
we find some alloys or
We
something
have
which we can.
nanotubes right now. Single wall carbon nanotubes is the strongest material
Mm,
which we use right now in space for many things. But maybe it has to grow, and I'm happy we have one big industry in Bangalore for that, Nopo Nano Power. It is run by my friend, and yeah, he wanted to do it big, so he did do that. So yeah, we have a lot of other things to find. Actually, not just the material. Many material scientists find new material every day. We need to understand those properties very fast.
mm.
Doing my one of my specialization in my masters was material science, MS, during my masters. So when we did it, it's not so easy to finding a new material is not difficult. Finding its properties, what they do, take long time. So we need to do it faster.
Good point. Um, Madhu, at the end, I always ask intelligent and smart people like you, what should me and my viewers read to know more about these things? And here you should also mention that your own book is coming out, so you can also tell that.
Okay, there are many science books. I would say, because nowadays documentaries is the new way to go. I say Carl Sagan's documentary is still a gold mine to look at for astronomy and astrophysics. The book that is coming up is for astrophysics and astrobiology part. I have put more of focus towards exoplanets, and also my research papers are involved in it. The book name is Extreme Habitable Environments, and it will be published soon. It's in the press right now. It is going through the procedure right now. So the book is from Taylor and Francis Publishers from Florida. So they're very old and very hard to publish. So I was happy that they gave me an opportunity to write a book. And I'm the primary author of the book, and I have a co-author called Usha Shekhar. So Professor Usha Shekhar and me have written this book. So it will be coming out most probably this year. So once it is up, maybe I can send it to this video's description link.
Yeah, I mean, once your book comes out, I will call you back again. We can discuss about your book. But first, I have to read it to have any
Sure,
doubts about it.
sure.
So, yeah.
So
So,
this book will contain for an amateur what is an astrophysics. I'll start with what is astronomy, astrophysics, and also slowly to take you towards exoplanets and what is the current astrobiology going on. That's the structure of the book. The caption of the book is a bridge between astrophysics and astrobiology. So yeah, I hope it helps as many people as possible.
great. Last question before we close this podcast. Which field you are most excited about, apart from yours? Which other field right now in astrophysics and astrobiology you are most excited about?
I should not say my field is not a bad. My field is very universal right now. Exoplanets is the hot cake right now. Other than the dark matter and dark energy are the hot topics of research right now in astrophysics and astrophysics. Exoplanets is gonna make us understand many things because we need to find a planet. So for our resources purpose, so that is one of the key things. Other than that, dark matter and dark energy helps us to understand the universe better. So we can't neglect our universe as well. So both are
Great.
very
I
awesome
mean,
topics.
yeah, I am also excited about these things. I don't know why, but somewhere in my mind there is some chemical always goes off when I think about these things. So that's why. So Madhu, thank you very much.
Thank you,
You
Arun.
came to this podcast, and please let me know whenever your book comes out, and
Sure.
maybe when after I finish it, I will call you back on this podcast, and we
Sure.
can discuss about just your book.
Yeah.
And that time I will be more intelligent and well read because I
You
have
are
been.
you are intelligent actually.
Right. So I'm just I just listen to songs. I remember some songs. That's how I do it. This I read many books on this, and I just remember 2% of it. So
When you
that's how
read
it is.
books, you tend to be intelligent.
Okay, I accept it. No humbleness. Uh, yeah, viewers, I hope you enjoyed this podcast. Please like if you like it, and share this video and make people aware about what's going on in the universe. And yeah, subscribe this channel. Help us reach 1,000 subscribers by end of September. Let's see if it happens. So bye bye. Adios.
Bye-bye.
Bye bye.
Check the mic and make sure it sound right, boys.